Okay, with Professor Farah. Okay, cool. So this is actually how your final exam is going to be set up. You'll have 40 multiple choice and 50 minutes to do it. Some of the problems you'll be seeing are about functions, structures, just overall general syntax. And then like it says up there, programming's all cumulative. So you just want to be familiar with a lot of the older stuff as well. So yeah, let's get started. And this is going to be pretty involved, so I want you guys to think of your answer and then try to guess it. So first question we have, can you guys read that, by the way? How long of a string can you put into a character array of length 10?
9.
What do you think? What's your name, by the way?
Drew.
Drew? Drew and?
Carrie.
Carrie. All right, so Carrie says 9. What do you think, Drew?
I agree.
Yeah, and why is that?
Terminating character.
Exactly, you need space for that null terminator at the end. Okay, number 2. We have a printf statement, and it's asking us for the % code, otherwise known as like the conversion character or placeholder. And it's saying, what would you put there assuming G has already been declared and initialized as a 2D character array? D? What do you think, Carrie? S or C? No, that's fine. So if we're working with a 2D character array, that's otherwise known as a string array. So if we're printing out just one of them, then it is going to be a string, so we would use %s.
Is this posted somewhere?
Yeah, I actually have it posted on the Study Union WordPress.
Okay.
The answers won't be posted on there, so if you want to just make a note of them, that might be a good idea.
And they'll be in
How's it going?
1, 2, 3, 4. So like if I write the answer for number
Yeah,
1,
yeah.
mine, it'll correspond.
It's all in the same order.
Is that the way if you're programming C? Like?
Yeah, this is Intro to C.
Okay.
What's your name, by the way?
Leonardo Damelis.
Can I go with Leo?
You can call me Nardo.
Nardo?
Yeah.
Got you. All right, cool. So let's move on to number 3. Here we're just going to look at the basic syntax of what a function signature should look like. So based off of those choices, what do you guys think is the a correct one there? A? What do you guys think? And then Nardo, what about you? What are you thinking? C? Okay. So for any function, we need the return type, right? We need the name. And we need the parameters. Does this all sound familiar? Hopefully. So let's look up right away. We have return types for all of them, so that's fine. With the name here, we actually have a space and then the name. Like we have a character here and then the name, so it can't be that one. We're still good on this one, and we're still good on this one and this one. Then we have the parameters, right? Void B, if something is void, you don't add like a variable name after it. So that wouldn't make sense. And then here we have integer, but we don't have the formal variable names there. We just have int and int. So then that leaves us with D, which we do have the return type, the name, and then our formal parameters with that variable name. Everybody's cool with that?
Whenever it's in the, when you're prototyping it, would it just be int and int?
Yeah, so if you actually do have it at the top, like before your main in the declaration, then yeah, it would be fine to not have the variable names. Good point. Cool. So did I get this all on the, okay, cool. I'm going to zoom in a little bit on this one. So this is just a tracing problem. I want you guys to look at it and try to go through it. I'll give you guys a few minutes. Hello, hello. What's up?
After the review, it's possible to get a copy of that, though?
So this is actually on the Study Union WordPress. The answers won't be on there, so if you want to just like try to keep track of them as we're going through it. But yeah, if you just go on the Study Union WordPress, you can find this. Dang, you guys can do it just by looking at it. It's impressive. What are we thinking here?
109 and 357.
What do you guys think? Is anybody? 109, 109. Okay, cool. So let's go through it real quick. With any tracing problem, you do want to keep track of your variables. So we have, within main, we have x, and we have y, right? So x starts at 357, y starts at 109. So we pass in y and we pass in the addresses of y and x. I sort of like tried to make it a little tricky, so I put in y and x, and then here it's called x and y, so you do want to look out for that. But we've passed in the address of y to here, and the address of x to here. So now, within the swap, we have x equals ampersand y, and y equals ampersand x. Everyone's with me? Yeah? I'm going to need some vocal affirmation because I can't see your faces. Yeah? Okay, cool. So we go with temp, right? Now we have temp in here. And we say temp is equal to dereference y. So we go to y, we dereference it, which means go to the address of, and we have 357 here. Then we dereference x, so we go to y in main, and we say it's equal to dereferenced y, which is 357. Still with me? So we change that to 357, and then we dereference y and say it's equal to temp. So we go to y, dereference it, and then go to x and set it equal to 357. So same thing. So then when we do print it out, it's going to be 357, 357. Any questions? Okay, cool. So it's all about just paying attention to the variables and then making sure you're just following through them correctly. I'll just blaze through it real quick for round 2 here.
So if at the end, if it was like x pointer equals temp, is that when it would switch or no?
Where?
Like at the end.
Oh, if dereferenced x equaled what?
Wait, like at the last line?
Mm-hmm.
Where if that was equal to like x equals temp, is that when it would switch or no?
Are you?
At any point. Like
You're saying on the last line, dereference y equals
Yeah.
temp. If we switch that y with x.
yeah.
Let me see here. So then we said dereferenced x is equal to temp. Temp is still 357. So all it would do is go here and set y equal to 357 again. This whole swap function is like messed up. for the whole purpose of this problem. But yeah, that's a good idea. So I'll just go through it real quick again. So we pass in these addresses, right? So now x and y, which are integer pointers, hold the addresses of x and y in main, but it's switched around for the sake of confusion. So x is equal to the address of y is equal to the address of x. We say temp is equal to dereferenced y, which is the address of x. So go to the address of x, get that value. Temp is now equal to that value, 357. Then we say dereferenced x, which x is holding the address of y. So we go to y in main and say is equal to dereferenced y. So we dereference y, go to the address of x, and then set it equal to that, which is 357. And then lastly, we say dereferenced y, which is holding the address of x, set it equal to temp, set it equal to 357. And then when we print that out, we get 357, 357. Everyone's cool with that? Cool. Let's keep going. All right, so take a look at this. Tell me if it's true or false. Drew says false. Any other takers? False. What about you guys? What do you think? Okay. Nardo, false. All right. Carrie, why do you think it's false? Float? What about you, Nardo? What do you think? Why is it false? Because of the float? Yeah, you could have a float in there. What's wrong with the float? All right, Drew, what do you think it is?
Is it because of the type def, you need an instance?
We need a what?
Is it called an instance? I don't know if that's the right word, but it's like after the last bracket.
So are you, because the actual issue with this, so yeah, it is false, but it's important to know why. When you use typedef struct like that, you need to have the name of the struct right there. So we would call it, yeah, I think that's what you were saying. You could call it something like user. If you didn't have this typedef, your struct would look like this. You would have struct and then use, I can't spell, and user. Everybody's good with that? All right, cool. Number 6. How's it going?
Good, how are you?
Everybody sort of thought of their answer? All right, what will happen if you try to write to a file that does not exist using the W mode? First off, what does the W stand for? Right, awesome. I kind of put it in the question, so that was not good on my part. But so what are we thinking happens if we try to write to a file that doesn't exist using the write mode?
Create one for you.
Yeah, so Drew knows. What'll happen is it'll create one for you. What if you try to write to one that already exists? There's just like extra information. It's not the question. Does anybody know? So what'll happen is it'll actually just overwrite whatever is already there.
I have no clue how to do it.
Okay, that's fine. So yeah, we have A there. All right, we have another fun old tracing problem here. I'm gonna try to, because I feel like it's a little blurry. Is that just me, or is it a little blurry? Oh, yeah? All right, I'm gonna put it on my computer, see if that's any clearer. Is that better? I think the issue is the projector anyways, but. So yeah, just try to trace through this real quick, and then I'll go over it. This is my review. What up, Kim? Oh, so if you guys ever want to look at this again, by the way, this is all being recorded, so it's all on YouTube. You could just look up UCF Study Union and just find my video. And that's also a way of me telling you guys not to like do anything crazy because you're being recorded. But yeah, or do something crazy. I don't know. That could be fun. But yeah, just try to trace through this problem, and I'll go over it in a couple minutes. So I know a lot of you guys are just like staring at the code, but it's really important to go ahead and actually write down what's happening, because it's going to be tough to do this all in your head. And like, oh, it's like early, you don't want to do it, but that's how you'll get the most out of this review. So I'd appreciate it if you guys could just try it out. Does everybody get surveys or no?
Yeah.
Should I? Oh, it's in my bag. And then if at some point you could fill this out, I'd appreciate that. Oh, my bad. Do I have paper? Yeah, you could just write on the back of this.
Okay.
Sure. And let me know if you need more. Thank you, guys. All right, cool. So I do want to keep moving forward, so I'm going to go ahead and show this problem on the board. Can everybody see the board, by the way? Hopefully, it's like right there. Okay. So as I mentioned before, with any tracing problem, you do want to keep track of all your variables. So right away, we have I, we have this array of size 5, we have A, B, C. This is how I approach like all my tracing problems, just because I feel like it's the most effective. So right away we're given the values of A, B, and C. So A is 9, B is 1, and C is 1. So then we go array 0 is equal to 12. We know 0 is that first index. So then we jump into our for loop. We have I equals 1. Array I, so we're looking at this one, is equal to array I minus B. So I is 1, B is 1. So this is going to be equal to this array plus A. So 12 plus A is 21. So did that make sense, how I did that? We did the math within the brackets, and then we looked at the previous array, and then added A. Cool. So when we say a plus equals a, what is that plus equals telling us? Exactly. So now we're saying a is equal to a plus a, which gives us 18. Then we say b equals c. B equals c. It's not really saying anything. I just threw that in there. And then we keep going, right? Now we're looking at 2. So then array 2 is equal to I minus b, which we know is 2 minus 1. And that b isn't changing values. So in your head right away, you could just always know that it's going to be the previous index. So we say array 2 is equal to 2 minus 1, which is this one, plus a. So 21 plus 18 is 39. Then we double a again. 18 plus 18 is 36. And then b equals c, you know, that's not doing anything. And so does anybody see the pattern at this point? Go ahead. Say that? 39. What about it? What do you think, Drew?
We're just adding what a becomes to the previous index.
Yeah, so it's like this index is going to be this plus a, and then when you're done, double a. So then 39 plus 36 is 75. And so a plus equals a. So then that's 72. And now we're at I equals 4. And we go, array 4 is equal to 4 minus 1, which is 3. 75 plus 72, which is 147. And then a plus equals a, we're looking at 144. And then b equals c. And we look again one more time. I is now equal to 5. 5 is not less than 5, so we break out of the loop. We print that out. And then our final answer is 147. Did everybody see that? Everyone's cool with that? Okay, cool. I'll leave this up until the next problem. Alrighty. Oh, sorry about that. All right, so this one is another tracing problem, and this one involves 2D arrays, so I want you guys to give it a try. I'll give you guys one more minute. All right, cool. Let's take a look at this. How did anyone feel? Did anyone get stuck, or they just feel like they didn't have enough time? Did anybody get the answer? Not enough time? Did anybody get stuck? All right, I'll take that as a no. Cool. All right, so right away, just want to go ahead and keep track of all our variables. So we have that 2x4 array. That first 2 indicates 2 what? Rows. Goes rows, columns. So we're going to have something like this, and then 4 columns. So 1. Cool. All right, then we have I and j equals j equals, and then we have t equals 15. All right, so we go ahead and jump into our first for loop. I is equal to 0, 0 is less than 2, so we go in. Then nums, which is the name of our 2D integer array. We say nums I3, so 0, 3, is equal to t. So we have 15 there. And we say t plus equals 2. So that just means add on 2 to what's already there, right? So we have 17. Then we go into another for loop, and we say j equals 0. 0 is less than 3, so then we say nums ij, so nums 0, 0, is equal to t. So that's 17. And then it says t minus equals 3, but that's not actually in the for loop. Do you guys see that? So that t minus equals 3 doesn't happen until after you break out of that j loop. So you guys want to pay attention to that. Because since there's no curly braces following the for loop, it's only going to look at that next line of code. Okay, so then we say, we reiterate, so j is now equal to 1. And we say num 0, 1 is equal to t. So 0, 1. And then, we keep going to 0, 2 is equal to t. And then we go to 3. 3 is not less than 3. So we break out of that loop. And then t minus equals 3, 14. Did that trip anybody up? Yeah, I just thought it was 2 for loops separated. No, it's all within that first for loop. But yeah. Cool. So we can keep going. Now we're at I equals 1. And we say nums I3 is equal to t. So nums 1, 3 is equal to t, which is 14. And then we enter this j loop once again. So j is equal to 0. And we say nums 1, 0 is equal to t, which is 14. We keep going. 1, so once again 14. Keep going one more time. 14. And then j gets to 3. 3 is not less than 3, so we break out. And then we have t minus equals, so that's 11. And then we go ahead and print that out. And what we'll get is 0, 0, which is 17, 0, 3, which is 15, and 1, 3, which is 14. Any questions or concerns?
So you said those are 2 separate for loops?
So you have that for loop. You have this for loop, right? These are the curly braces for that for loop. And so within that, you see this for loop. Make sense? And then you have these print statements still within your main, but outside of either loop. So everyone's cool with that? Okay, cool, cool. So we can move forward. So we're looking at number 9. Yeah. Got to keep you on your toes. Me neither. All right, what do we think? This one shouldn't take too long. Let me see some hands. Who thinks they have the answer? B? What do you guys think? B? Any different answers? Maybe D. Okay, cool. So let's just see why each one is how it is. Why isn't it A? Yeah, so we don't know if Word already has something in it. We want it to just be B. strcat would cat that to whatever is already in the string. So it's not that one. B, we add it in character by character, and we go word 0 through word 3. Everything there looks fine. And so B is actually the answer, but I want to keep going. So then why isn't it C? Does anybody see why? What's that? So you're saying you can't copy it to the word B? Is that what you're saying? Okay, cool. So the issue there is the way strcopy works is it basically says, actually let me switch to the Word document so I can type stuff out. Okay, so the way strcopy works is the first parameter is basically where you want the string to go. So if you were to use strcopy, you would put word here, and then you would put B here. And an easy way to remember this is basically by saying this first parameter is equal to the second one. So it'd be like, it's like an assignment statement, right? Oh, that's really small. So this is sort of like the slang for it, I guess, how you would look at it here. Does that make sense with everybody? Any questions? You guys can ask questions, like that's fine. No? Everybody's like, yeah, this was...
Did you have to add that terminated character for B?
I mean, if you wanted to do it properly, like you could leave it out and hope for the best when you go to print it. But for good code, you would want to add that null terminator because it's not going to do it for you if you try to put it in like that. Oh. If you did do something like word is equal to B, when you declare it, it will go ahead and put that null terminator for you. But that's not how we did it in this problem. All right, cool. So this is another tracing problem. I want you guys to try that out. My God, what is that noise? Always. Nardo, you know this is all on the WordPress, right?
Oh, okay. But I take picture, I can take note too.
Gotcha. All right, so I'll give you guys 2 more minutes. What's that?
The backslash
Backslash
T.
T just means tab, like how a backslash N would start a new line.
Z backslash equals.
Oh, that's just divide equals.
Oh, okay.
Yeah, like in the same way you'd have plus equals. Anybody have any guesses? Kim, what do you have? Mm-mm. Any other guesses? It's okay to be wrong. Is anybody just still working on it? All right, cool. So I'm gonna slowly make my way to the board while you guys finish that up. Let me check, but I think so. Yeah. And then do you have the other two?
K is going to be equal to. Is it not arbitrary? Like what the address would be?
Well, we have dereferenced K.
So is it 12?
What's that?
12?
Mm-mm. Is K 9? No. Yeah. Anybody know what B is equal to?
3.
Not quite.
35.
No, okay. All right, so let's go ahead and trace through it. So we're given Z equals 27. We have pointer K is equal to the address of Z. And then we have B is equal to dereferenced K. Everybody sees the difference there? We declare it with an asterisk to indicate that it's a pointer, and then right away we dereference it. We're not saying B is equal to the address of Z. We're saying B is equal to whatever the address of Z is holding. So B is equal to 27. Did that trick anybody up? Because after you declare it with that asterisk, anytime you have that asterisk there again, it means you're dereferencing it. So right away we dereference it and we give that value to B. So then we set K equal to the address of B. And then we say Z, so we know we're going to change the value here, is equal to dereferenced K, which is 27, times 3, which is 81. And then we say Z is divide equal to dereferenced K, so we know we're going to change that value again. And we have Z is equal to 81 divided by dereferenced K, which is 27, which puts us at 3. So then we keep going. We say dereferenced K, so we go to we go to the address of B, and we divide that by Z, which is 3. So 20. Okay, I'm on dereferenced K divide equals Z. So we have dereferenced K, which is B, divide equals Z. So 27 divided by 3 is equal to 9. And then on that last line, we have dereferenced K divide equals Z. So then once again, we have 9 divided by 3. Yeah, okay. So then we have 9 divided by 3, which is 3. And then we switch the address to the address of Z. And so Z. And so we print that out, and we have Z equals %D, which is 3. Dereferenced K, which is the address of Z, is equal to 3. And then we have B. I think I might have done some math wrong, because this should be 9. So what's that? Did I read the same line twice? Okay, I think that's what it was too. So yeah, don't make that mistake.
So I'm trying to like put this in like kind of like a table,
Mm-hmm.
or like a variable column, value column, and an address column, because that's kind of what they do in Skybooks.
Okay.
But I'm kind of getting like lost, just like even writing out what they are
Yeah.
usually equal to.
Okay, I'll go through it one more time, just because I also want to do it right, because I messed it up. But again, we just want to start off with all of our variables, which in this case are Z, K, and B. So we start off with z equals 27. Pointer k is equal to the address of z. And then b is equal to dereference k. What does dereference mean?
Well, I'm sorry, 1 second before we move on.
Mm-hmm.
That pointer k equals the address of z, so would that just be the value of k equals 27?
So right away, the address of z is some value. We don't know what it is. It could be like 0 times FFE8, you know, like it's anything, which is why I indicate it as &z, but really it's holding some hex value. But that hex value doesn't matter. What does matter is that it's the address of a different variable.
Okay.
Does that answer your question?
Yeah.
Okay. And then b is equal to dereference k. So we dereference k, which means go to the address of, and in this case, we just want to pull that value and set it equal to b. And then we say k is equal to &b. So now k is no longer pointing to z, it's pointing to b. And so we move on to the next line. Z is equal to, right away, we know we're going to change its value. It's equal to dereferenced k. So we go to k, dereference it, which means go to the address of. We have 27 times 3, which is 81. So then we're on the next line. Z divide equals, so once again, we're changing the value of z. Divide equals dereferenced k. So we dereference k, go to the address, 27. So 81 divided by 27 is equal to 3. And then we have, am I on? Yeah, I already did the times 3 divide. Okay, so now we have dereference k is divide equals to z. So we dereference k, which means go to the address of. So we're at b. Divide equals, we know we're changing its value. Divide equals z, which is 3. So 27 divided by 3 is 9. And then we have one more line, which is k is equal to &z. And so then when we do print that out, we have z equals %d, which is 3. And then dereference k, we dereference k, which is the address of z. It's also equal to 3. And then b is equal to 9. Any issues with that? Drew, you look like you want to say something. You got it? Okay. Awesome. Again, it can be a little tricky, but it's just really important to keep track of all your variables. All right, cool. So I thought this was a little appropriate for, finals week. So write a program that places a string anxiety into a character array just large enough for it, then prints out the string in reverse order. So I'm going to go ahead and move to my compiler. Let me delete this. And then let's go ahead and get this so we know what we have to do. And then you guys are going to help me out with this. All right, cool. So we know right away we want to declare a character array for working with strings. So we'll call it str. And then how long do we want our character array to be if we want it to fit just that string? What's that?
And the null, like in B.
Yeah, of course. 7, yeah. Because anxiety is 6 characters, 1, 2, 3, 4, 5, 6, 7. Anxiety is 7 characters. So we actually want, we want it to be size 8 because we want it to have enough space for that null terminator. So right away we could go anxiety, and that would be fine. But I want to use string copy so that you guys are exposed to it a little more. So what's the first parameter that I put? Would it be the word or would it be my character array? The array? Awesome. Because like I was saying, it's basically saying like this is equal to the next one, right? And then would I just put it like this? Anxiety. In quotes? What kind of quotes? Awesome.
You don't have to add the brackets for str.
What do you mean?
In the string copy.
No, because that's giving it the pointer to where it needs to go. So we have that, and then we want to print it out in reverse order. So can anybody think of a way to do that?
I got an example of it, but
I don't want to hear the example, Drew. I want to know what you're thinking. Anybody just off the top of their head, can they think of ways to print this? What's that?
Could you do a loop and like iterate backwards?
Yeah, that's exactly what I was thinking. Awesome. So I is the go-to for counters, and then and in this case we want to print the y first, and the y is which index in the character array? 6. So then we want to start at I equals 6. I is greater than, do we want greater than 0 or greater than or equal to 0? Yeah. And what's your name? Manisha. And then y greater than or equal to?
Because you want it to go from the last character to the first character. So you want to go to y to a.
Yeah, exactly. Because we do want to print out that 0 index. So that's why we want to do equal then. That way we hit that last one. And then we have I, and then what goes here? Because 7, 8, 9. No, I'm just kidding. Why is it 6 instead of 7? I was just going off of Drew's word, but if we were to draw out the array, we have we have 1, 2, 3, 4, 5, 6, 7, 8. So then we have A here, N, X, I, E, T, Y, and then backslash 0. So we want to start from here. And yeah, so this is 0, 1, 2, 3, 4, 5, 6. Does that answer your question? Okay, cool. And then like you guys mentioned, I minus minus because we want to iterate backwards. And then we would just say printf %c, and we'll get it on a new line. And then what goes here? What's the variable? Just like that? Kim, louder. You're on YouTube, you're a star. You gotta speak with aplomb. I, and then we're done? All right, so we can go ahead and run that. And I don't know if you guys can see that, or you can just take my word for it. It does print it out in reverse order. So nice job, guys. Any questions with this?
that's way easier than my example.
How did yours do it?
Well, it started at I equals 0, and then it said I is less than like the number element. Well, because this was for numbers divided by 2, and plus plus I. And it was like setting temporary values -1.
Does seem a little more convoluted. Cool, everyone else is fine with this? Awesome. So then let's keep going forward. And then we were doing it on the Word document. Okay. So then I went with another finals themed program here. But in this instance, we're just gonna fill it out. This is some file IO, which I know some of you guys might be rusty in. But yeah, let's just go ahead and try to fill this out. I want you guys to just try it on yourself. Try it with yourselves real quick. No memory of it? Yeah, file IO is like really ugly. But it's not too bad once you get the hang of it, which is really all coding. All right, cool. So this is like pretty much memory. Either you know it or you don't. And if you don't, it's fine. Depending on when your final is, you probably still have a few more days. But this is just basic syntax of file I/O, so let's jump into it. So fopen, can anybody tell me what fopen does? What's that? Yeah, so it kind of does exactly what it's called. You give it the name of the file and then the mode that you want it in, and it basically gives you a pointer to it, which is why you have your file pointer equal to the result of that function. Does that make sense?
What's the very first line?
Where?
Is that just like creating a file?
So this is declaring our file pointer. This is what is going to let us work with that file in the first place. Does that make sense? Okay, cool. So fopen is taking two parameters. It's going to go ahead and take in the name of the file, which is called finals.txt, and you have it in double quotes. And then the second parameter will also be in double quotes. And does anybody at this point remember what it is? R? What do you guys think? No, you got it, Drew. What's that? Off the top of my head, I don't remember if you could do R+, but the easiest choice here would just be write, because we're writing that string into the file. So then we would put it like this. And so that tells your compiler basically where you're going and then what you're doing with that file. Everyone's cool with that? All right, so that moves on. So we're moving on to the fprintf, which an easy way to remember the syntax of it is that it's going to be exactly like a printf. So you could just put exactly what we're trying to do, which is %s, as if we were printing it to the console. We'd have our comma, and we'd have str, right? Everyone's with me? And then just remember to tell it where it's going, because it's not going to the console, it's going to the file. So that's why we have our file pointer there. The file pointer, no. Bless you. So yeah, printf and scanf, fprintf and fscanf are structured the exact same way as printf and scanf, except that the first parameter is that file pointer. It's basically asking like, okay, where do I put this stuff? Or in the case of fscanf, like, where do I get it from? And then that leaves just one last thing, and does anybody remember how this goes? What's that? Yeah, the name of our file pointer, because we don't want to put finals.txt in there. But yeah, if we actually go ahead and run this, Oh, okay. So something about using the quotes in Word like messes it up. So then we can try that one more time. What's that?
Behind the dot text, you have to do those ones.
I'm just going to rewrite it. Finals.txt, and then W. So then we can try that. Cool. So we didn't get an error there. And then if we check our, we have finals right there. And then if you guys can read that, it does in fact say stress. Is everybody cool with that? What's up?
I think that when we were going over this in class, we did this section, like the file section, before doing all the strict stuff.
Mm-hmm.
So I think we did a for loop instead because we didn't have like str copy to utilize.
Okay, you were like throwing stuff in there character by character, you're saying?
Yeah.
Okay, yeah.
So instead of doing the for, we don't do the for loop here because we have the str copy, right?
Right. If you wanted to do this in a for loop, it wouldn't take a whole lot of adjustment. You would just end up doing it like this. And then I'm guessing you wouldn't have, you said you didn't have str copy yet? So then you could just go like that. It's not great to hard code string literals, but for the sake of this program, you know, it's not a big deal. And what you would actually do there is you would go ahead and put this in a for loop. And then stress is 3, so I equals 0, I is less than 6. Yeah, and then I plus plus. And then we'd have to change that to a character. And then we'd change that to I. And then okay, yeah, I think you can only have that in the declaration. Yeah. So my mistake there was trying to initialize str here outside of the declaration. If you ever want to initialize a string in this by setting it equal to that, you have to do it within the declaration. And so then if we go ahead and actually check our finals.txt once again. I know you can't read that, but it says 11:03 a.m. on the time, which means it was overwritten. And so we open that again, and it still says stress. Any questions? Cool. In our case, nothing, because we're working within an IDE. But if you're working in like a software company and multiple people are trying to work on the same file, if you don't close it, you'll run into some issues where somebody might not have access to it. So then let's keep going. All right, so here we have another lovely tracing problem. I'm going to get some water. I'll give you guys a few minutes to tackle this one. Yeah, I'll just take this. All right, we go ahead and so this one's not too bad, hopefully. Anybody got it? I need like some mumbles or like, because I'm looking at the back of your head. Still working? Okay. What's up? Yeah, go for it. Yeah, you got it. Did anybody else get 28 or is on the track to looking like getting 28? Cool. Okay. All right, so I'm going to go ahead and trace through it. Boom, 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 boom. Okay. So first things first, R equals 3, M equals 7. So then we say M is equal to Z. Z is the name of the function. And we pass in M as the first parameter. So M equals 7. And then the second parameter, we pass in M minus R, 7 minus 3, so that's 4. We have R equals 4. Then we have another variable there, Z equals 0. And then we have I, and it is uninitialized. Yeah. What's up?
Wouldn't in the C function n would be equal to 3?
We pass in R. Yeah, you're right. Good catch. Got to keep you guys on your toes, you know. Not really, I just wrote it wrong. Okay, so we have Z equals 0, which we have, and then I no value, and then right away, I is equal to 0. Then we say for I is equal to 0, I is less than R. R is 4, so we know this loop is going to run 4 times, I plus plus. So then Z plus equals M plus R. So M plus R is 7. So we have 7. And then right away, you know this loop is going to run 4 times. M and R aren't changing, so it's always going to be 7. So it's going to be 7 plus 7 plus 7 plus 7. Does everybody see that? Did anybody get tripped up on anything or was unsure of something? No? All right, cool. So just for the sake of it, 1, and then plus equals M plus R, which is 14. And then you do that 2 more times until you reach 4. 4 is not less than 4. So then you would break out, and then you would return Z up to M. So M is now equal to 28. And then we would just print out M, and we get 28. Everyone's cool?
When would your value stay the same? Like in class, she's doing a positive value,
Mm-hmm.
and then when she printed out after doing everything to like a number, it stayed the same.
So that's if you were working with a pass-by value. Like if we were working with something like this, you saw how we had R equals 4 here, but in main we have R equals 3. So it's almost sort of that same line of thinking, that this R, even though this is a different value, since it exists only within our Z function, it's not going to change anything back in main. Which is why when we do a swap function, we do it pass by reference. So we can go ahead, go back to those addresses and actually change those values. Make sense? Cool. All right. What number will strlen return for that string? This one should be quick. 6, what do you guys think? 6. Manisha, what do you think? 6?
Because you're gonna return it as string.
Cool. So the way string length actually works is that it goes, okay, is this equal to the null terminator? No? Okay, let's add 1. Let's keep going. Let's keep going. Add 1, add 1, add 1. And then when it gets here, it stops. So it doesn't actually count this. So string length for this would only return 5. What do you mean? Yeah, if you were like inserting it.
Through it, right? We'd kind of take into consideration that null, but if we're reading just the string, we just.
You're saying if we're like looping through and printing it?
Yeah.
Well, if you print the null terminator, like you're just printing an empty space.
But like with the example we did before where we counted the null.
I mean, yeah, if you wanted to. But again, like in terms of printing the null terminator, it's just like an empty space. And string length won't count it when it's going through its code. All right, cool. 15, what do you guys think? 5. Yeah, it's 5. What do you guys think? You said A? A or E? Okay. Any different choices there? What do you guys think? You said E? Kim, what's the answer? Is it E? Any different answers? Okay, so let's go through the options. And we'll start at E. No, that wouldn't make sense. We'll start at A. So why can't it be A? Can anybody tell me? What's that? What are you referring to with that? Well, yeah, you can. But the issue here is we have, what we're saying here, int nums, is it equal to 0? Because we have 2 equal signs here. And that's usually used for comparison.
In that if statement.
Yeah, in an if statement and a while statement. Whenever you're checking if something is equal to something, you use those 2 equal signs. Which takes us to B. Int nums 23 equals curly brace 0 curly brace. And this will actually go ahead and initialize all of them to 0. So B is your answer. But I do want to keep going. Why isn't C the answer? Or one of the answers? Yeah, so our first index would be 0, but then it'd be 1, 2, 3, etc. And we just want them to all be 0. So then logically it can't be D or E, and our answer is B. This is like a little shortcut, and it'll only work with 0 if you put another number in there. It'll just initialize that first index to that number, and then the rest of them will be zeros. No, because we're doing it in the declaration. We have int nums 23 equals 0. If you did have, like after the declaration, nums 23 equals 0, well, first off, it would go to an index that doesn't exist because there's no 23rd index, and then it would set that one to 0. Does that make sense? All right, cool. Let's keep. Yeah, the answer is B. Cool. Da, da, da. Can you guys see all the code for that? It's like kind of small. All right, we'll come back to that one. That one's a little long. All right. Can you guys all see this one? And I'll delete this because this isn't important. That's all legible, right? Cool, cool. All right, so based off of the code down here, I want you guys to fill in this struct. And if there are any arrays within our struct, just make them length 10. I'll give you guys a couple minutes. Say that again? Oh, we just did 15. I skipped 16. We'll come back to it later if there's time. And then if you guys want if we don't get to any of the questions, just come up to me for the answers if you do want to look at that review later. Swim with the sharks in the deep blue water. Nice. Oh, does anybody like coffee, by the way? Yeah. So as incentive for this problem, if anybody gets it 100% right, you get this. I'll come up to the front. You can have this 10 free American brew refills from Cafe Bustelo. So, get it right. And then if 2 people get it right, I don't know, like rock, paper, scissors. Or actually, if 2 people get it right, like you guys can get this cup. And then if you think you have the answer, just come up here and I'll let you know. What's that? Yeah, just come up here.
Embarrassed if I get it wrong. We've gone over this so many times.
No, it's okay. Where is this? Is 17. Yeah, no.
Oh man.
You're close though.
I let you down.
It's all good. What's that?
Is this a double pointer?
I don't know. I got no clue. I got no idea. Yeah, it's pretty bright. Let me see.
I know. No.
Good try though. All right, I'll give you guys like 2 more minutes. What's that?
I
Mm-hmm.
I don't know what like the OP does, but
The OP?
like at the very first line
Oh, okay.
of the main. But
I'll,
I don't know like with the array choose 0.
I'll go over it.
Cool.
But I don't really like coffee, so I'm trying to give this away. But I'm not just going to give it away. Is anybody still working on it? Okay, cool. So let's go over it. I'll just do it from here. Okay. So the first thing we see is hat, right? So we want to just try to do this in order. We go to the main code, and then Drew, what this OP is saying, because look at the name of our struct, right? It's called O, and so I declare an O struct and I call it P. That's all that's happening on that line. So for hat, we see hat. We see a lot of interesting things here. We see the address of an index of hat is a character, right? That's what this is telling us. I'll go in order. But yeah, I'll hit this line in a second. So we have, which means p.hat0 is a character, right? If that's what's happening on this line. So then if we have just p hat, what do we think that is? Based off of one index being a character, what would the whole thing be? Anybody just shout it out. What's that?
I don't even know what question.
Okay, maybe I'm phrasing it weird. So if just one index of hat is a character, what is the whole thing? Yeah, it's a character array. So then hat would be char hat, and then they're all just length 20. So that's what that would look like. So then let's look at shoe. This one's probably the trickiest one. But we see p.shoe0, and then we have it within strcopy, and we're copying a string in to a single index. So if a single index is a string, what does that tell us about shoe as a whole?
Double array.
Yeah, so you mentioned it earlier. So you were definitely on the right track. But shoe is a string array, otherwise known as a 2D character array. So Kim, you're actually really close. I think this is the only one you missed. And then x, I think x is just, yeah, x is just an integer. And then, does anybody know what flow is? What's that? Speak up. Any other guesses? Just the regular old float. Cool. So if we look at our p flow, I didn't think about that. If we look at flow, we have it set equal to &y. And y is a float, which means flow can't just be a float. It's going to be a float pointer. Does that make sense with everybody? Everybody's cool with that? Yeah? All right. All right, so I want you guys to do this on your paper. So write this function called deathmatch that takes in 2 integer addresses and sets the smaller one equal to 0 and returns. If the 2 numbers are equal, return right away. Anybody have it? Drew, you said you think so? Thank you. X plus y.
Oh, and then put a else. You're invalid.
Okay. So it's close. You're missing a couple things. Anybody else think they have it?
It's just like the pointers that I'm missing.
Mm-hmm. And then also that break, you don't need a break there. Because it's not a switch statement and you're not breaking out of any type of loop.
So you just say just return.
Yeah. So you'd want to return.
Same thing though?
Because what break does, break works within loops or, yeah, basically, oh, and then also switch statements where it'll break out of whatever it's within. So it'll break out of a loop or it'll break out of a switch statement. I don't think it'll break out of a function. Cool. So, Jesus. I'm going to get you guys to help write this with me. My mic came off, so give me 1 second. All right, cool. So then let's go ahead and write this. And we want it to be called deathmatch. Cool. So we know we're going to be using some if statements, some else if, maybe an else. What's the first thing we want to check? Somebody just say it. If, say that again. Equals y? Oh, Jesus. Equals y. What do we want to do? Yeah, so we would return, would we return x or y? Why is that? Yeah, exactly. Our return type is void, which means we're not returning anything, so we would just put return. What's wrong with this? Not quite. We don't want the address of x and y. We want to dereference x and y. So, what's that? Yeah, we would want that asterisk. Return. Then we could do else if, whoop. And then what would go here? Dereferenced x is less than y. And then what goes there? Asterisk x. Yeah. Wait.
Do we need an asterisk at y?
Yeah, we do. Cool. And we set that equal to, Jesus. We set that equal to 0. Okay. And then we have one more condition, right? So we don't even need it to be an else if. We could just write else. Else doesn't have a Boolean comparison there. So we could just put else d referenced y equals 0. And then you don't need return statements in the else or the else if because only one of these three things is going to happen. So after that happens, the code will just terminate. And then with any function that we write, we do want to test it. So then we can just printf %d, and then we'll do death match. Then we got to make some integers. Int x equals 78, and then int y equals 46. So then we could do %d, and then, yeah, I'll just call this outside of the print statement. X equals, y equals %d, x, y. Cool. So then we can run that, and what do we expect our output to be? What's that?
Wouldn't we need the ampersand for x and y?
Yes, good catch, good catch. That one I actually did leave out on purpose. Okay, cool. So what do we expect our output to be? Yeah. So then when we run that, we get an error because we have an 8 there for some reason. And then, yeah, we do have our function working properly. I'm not sure if you can read that, but it does say 78 and 0. And then you always do want to test that out. So we try it with y, and then there we get x equals 0 and y equals 100. And then lastly, you want to check if it works if they're all the same, because you do want to make sure that your function is working properly in any condition. And it is. They're both equal to 78. So nice job. Is everybody fine with this code? Everybody understands it? I need some nods. I can only see the back of your heads. Cool. Yeah, because we're passing in those addresses x and y.
So in the main function, you always want to make sure you're passing the address with the ampersand.
Exactly.
Okay. And then when you're doing your function, it's always going to be asterisk.
Yeah, because the pointer x that we have declared as one of our formal parameters, this integer pointer x holds an address. You wouldn't be able to put something like that because that's indicating the address of x, and then this is basically the container for integer addresses. Drew, did you have a question?
Yeah, so we wouldn't need to prototype this function before main.
Oh, okay. So that's something that CodeBlocks actually just went ahead and was like, oh, okay, they must have forgot it. We'll just work with it anyways. Because CodeBlocks is pretty forgiving. But if you did run this on something like a Linux server or some sort of command line prompt, you would want to prototype it just like Drew said. So good catch.
You also wouldn't need the x and y, or
Yeah, so you wouldn't need there.
you would need the pointer.
Yeah, because that's the data type. But yeah, cool. So then we can keep going, and then I'll save this one for later, and we can go to 20. All right, so number 20. True or false? This function takes in a person struct pointer and successfully prints out its contents. Kim, if you don't know this, I'm going to be upset. True? What do you guys think? True. So, it is actually false. It's all good. So this function takes in a struct pointer, yeah? Everybody sees that. We have our struct called person, and it takes in a person pointer. And in this instance, we just called it user. Everybody sees that, yeah? So then, when we go ahead and try to actually work with our struct, because this is a struct pointer, you wouldn't use a dot, you would use the arrow. So if we change the dots to arrows, then this would work properly. Or if we just got rid of this and made it a function that just takes in a struct, then the dots would work fine. But if you're working with a struct pointer, you're going to be using the arrows. If you're working with a struct, you're just going to use the dots. An easy way to remember that is just if you're working with a struct pointer, you'll use an arrow. An arrow is something that points, so not too bad there. All right, so the class that I was doing SI for did touch up on recursion. How many of you are unfamiliar with recursion? Just raise your hand. Everybody's just been, okay, so is your hand up? Okay, cool. So pretty much everybody has seen at least a little recursion. So I want you guys to just try to run this code like on a piece of paper and tell me what it does. Recursion is definitely hard to like visualize, at least for me. So I always try drawing it out. So does anybody see it? And a good way to just run codes on paper is to just pass in some arbitrary value and try to work with that. Because if you try to run it like just off of how it looks like a general function, it's going to be hard to do. So I want everybody to pass in a 4 into this function, like just the number 4, and try to see what that value gives you. And then the same coffee/cup rewards apply for this one if you get the answer to 4. I'll give you guys 2 more minutes. Is anybody still working on it? Any guesses?
144.
Mm-mm.
Yeah, I don't even know if we went over this, to be honest.
That's okay. Recursion's very slippery. Is anybody still working on it? If it's just silence, I'm going to assume no. What's that? Are you? Okay, cool. So let's go ahead and draw this out, and then I'll do it with the number 4. So the whole point of recursion is to have a function that basically calls on itself until you hit the base case. Our base case in this instance is if x is less than or equal to 1, return 1. So if we pass in a 1 or a 0, eventually it's going to return that 1. And so the whole point of this is so that as you're recursing and you keep calling the function, eventually it's going to hit this base case and then pull you out. This is basically what is going to end up terminating the recursive function. You have a base case in any sort of recursion that you work with. So in this instance, we're passing in 4. So x equals 4. X is not less than or equal to 1. So we do say return 4 times, and then we call that function again. But this time, do you guys see that we pass in a 3? Everybody sees that. So then we pass in a 3. Our function is called y. And so let's take this over here. So then we have x equals 3. And then 3 is not less than or equal to 1, so we keep going. Then we say return 3 times x minus 1, which is 2. So then we keep recursing. So now x is equal to 2. X is not less than or equal to 1, so we return 2 times 1. And so finally, you guys see that we're going to hit our base case, right? So we say x is equal to 1. So then right away, we see x is less than or equal to 1. So we return 1. So we go here. So now we're at 2, right? Yes? So we're at 2. And so now we're returning this 2 over here. So 3 times 2 is 6. And then we return this 6 to here, because I know it's sort of confusing to follow. But the result of each one is basically just like reversing all back to the original function call of y here. So then we have 4 times 6, which is 24. Any confusion with that? And so then at this point, do you guys see what this function does? Exactly, yeah. It takes in the factorial. So if we had passed in a 5, it would just be 120, because it would be this whole process, but with 5 times 24. Do you guys see that? So then, that's how that would work. I know it's a little confusing, but I have one more recursive function. Maybe that one will be a little easier to see. Cool. So how many times will bananas be printed? How many bananas, people? I gotta know. How many?
3.
Okay, what do you guys think? Any different answers? Kim? What's that? Okay. Cool. So why do you think 3, Drew?
Because, so you jump into the first for loop
Mm-hmm.
at I equals 0, and then you jump into the second for loop at still I equals 0.
Yeah.
And then you're going to do that 3 times, because I is 0, then I 1, and I 2. And 3 is not less than 3, so that's 3 times. And then it's going to jump out of that for loop and go into the first for loop. And then, but I is already, oh shit.
So I at this point would be 3, right?
Yeah, okay, yeah.
So then 3 is still less than 6, so then you would I++. And so it wouldn't, what's that?
No, sorry.
So it wouldn't print 3 times or 18 times. Does anybody, what's that?
9 times.
Does anybody see what's happening here?
6 times.
Okay, so I think this has a little more effect if I just show you. So this is actually printing out infinite times. Does anybody see the reason why? Mm-hmm.
And then it's always just going to be up to 3, which will always be less than 6.
Yeah, yeah. That's exactly right. So what happens there is we have this loop that runs until I is no longer less than 3. So this means it'll break out when it's at 3. And so it'll come here, it'll say 3 is less than 6, cool. Let's iterate this loop again. And it'll say, let's run this code. And then I will be equal to 0 once again here, because we're starting the loop like brand new. So then it'll just keep running forever.
But if you use different, instead of I's in that second for loop, then if you use like J.
Yeah, I want you guys to also answer this question. If we used a different counter, how many times would that print out? You guys say 18. Nardo, do you think otherwise? 18. All right, cool. So that's exactly right. It would print out 18 times. That's 18, probably. I don't want to count that. And so it goes through this loop 6 times. And for each iteration of this, it's going to print bananas 3 times. So 6 times 3 is 18. Okay. So then this has to do with malloc and calloc. So which one of these successfully allocates an integer array of size 10? What do you think?
Well, I don't know if I've ever heard of calloc, but I would say D. But if it's for array, calloc means for array, then it's A.
Okay.
So I would say D.
Okay, cool. Any different answers? We got 1D, not the band. What's that? D. You said A? Can anybody tell Drew the difference between calloc and malloc? Yeah. So malloc will just return a pointer to the memory, and that memory just has a bunch of garbage in it. What calloc will do is it returns a pointer to that memory, and it'll set it all to 0. Or if you're working with like an array of strings, it'll set it all to null. But basically, it sets it to like it's 0 or it's null. And calloc also, the syntax for it is different. Calloc takes in 2 parameters, while malloc takes in 1. But in terms of this answer, D is the right answer. So what malloc does is it takes in the number of bytes. And does anybody know how many bytes an integer is?
16 or 32.
So that's bits. How many bytes is it? What's that? Yeah, 2 to 4. So in different instances, we don't know how big it's going to be, which is why we put size of int instead of just putting in 10 times 4 or 10 times 2, because we're not sure, right? But calloc here would be the wrong choice, because calloc takes in 2 parameters, the data type and then the number of bytes. Malloc here would be wrong, because even though malloc would give you 10 bytes of memory, it wouldn't give you 10 integer-sized indices of memory. And then calloc here, the syntax is wrong, and so we're left with D, which is the right choice. All right, cool. So I want you guys to, once again, try this recursive function, and I want you to try it with the number, we'll try 5 this time. And then if you're able to tell me the right answer, then we can go ahead and get you caffeinated. Or, you know, get a cup, either or. What's that? Yeah, just try it with a 5. Hmm? Oh, true. Try it with a 5 and a 3. Yeah. And then not only do you need the right answer, but I want you to tell me what the function itself does. So if you want to like plug in your own numbers, test it out, that's up to you. In the nighttime, we go riding. Swim with the sharks in the deep. Oh man, we're almost out of time. All right, I'll give you guys another minute. You got it?
You said 5 and 1. X equals 5 and y equals 3.
Yeah, so you got the answer, and then what is the function doing?
To the n power to the y power. No, well, x times y.
Yeah, okay, cool. So then which one do you want?
Take the cup.
Nice. Cool, so Drew over here actually got it. Does anybody else think they have it? There's still a cup up for grabs. No? Okay, cool. So, what we're doing here is we're passing in 2 numbers. In this instance, we pass in a 5 and a 3. So we have x equals 5, y equals 3. So we say if y is less than or equal to 1, return x. Otherwise, return x plus, and then we call the function again, and we pass in the same x, but then y minus 1. So then we are now down here, and we say x is equal to 5, y is equal to 2. We haven't hit our base case, so we keep going. Return x plus same function, but y minus 1, so now we're at 1. And then we're down here. I'm going to make this a little more clear. And so now we're at same thing, x equals 5, y equals 1. And so in this instance, we do hit our base case. So we have, we return x. So we return x to here, right? Because this was the result of this function call. So we have 5 plus 5, which is 10. And then we return this 10 to this function call. So we have 5 plus 10, which is 15. And so what this function is doing is it's just basically multiplying these two numbers, but it uses recursion and addition to do it instead of just saying x times y. Any last second questions? Anything that I might be able to answer in like a minute? Just any concerns? I'll take that as a no. So yeah, that's all the time we have. Thank you guys for coming. Sorry I wasn't able to get through more material. Can I erase this?
Wait, I'm staring at it.
Okay. So it's sort of like each time going a level deeper. And then when you return, the value that you're returning becomes like a substitute for this, like the result of this. And then you add it with x. And then you return it again to that original function call. And then you're left with that actual number.
So you're not, like with your calculations, you're just working with x, but your y is kind of like a counter.
Exactly. Your y is basically what's going to allow you to eventually break out. Because that's how we set up our base case, which is if y is less than or equal to 1, return x.
Okay, so that's why as soon as you hit 1, then you start plugging in upwards.
Yeah, you start sort of reversing.
Okay.
Cool?
Thank you.
Yeah. And then if you guys could fill out those surveys, that would be awesome if you haven't already.